The first three questions are converting the large numbers into a 16-bit mantissa and 8-bit exponent notation. And then the second three numbers were converting small binary numbers, again, into a 16-bit mantissa and 8-bit exponent notation, using 2's complement for that one for the exponent, because the exponent in that one is negative. So I'm going to go through the first one with you. On this screen here, I've basically set up a table of values so that we can convert this into binary first of all. So converting as we normally would, I've put in an extra couple of steps on the table here. So we've got the 1024 and also 2048, but you can see that that actual value there is too much for this one. So we actually don't need that column here. So when I do this conversion here, I've got obviously 1 in the 1024, subtract that from your 2045. We also need 1 in the 512, also need 1 in the 256, and so on. I'll keep going down because basically you need all of these as ones except for the 2. Now, we've also got a decimal value in here. It's 0.125. So I've added on these other columns to include our decimal values. Now, the decimal value is just, you go half of 1 for the 0.5, half of 0.5 gives you the 0.25, half of 0.25 gives you the 0.125 there that would require. Okay, so that's our actual value all written out in full. What I can do then is I'm going to write down this value as a mantissa. Now remember, it's a 16-bit mantissa that I want to be writing in here. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 ones, then a 0, 10, 11, 12, 13, 14. And I need to add on these extra 2 zeros to make it a 16-bit mantissa. I'll just make this look a little bit bigger for you. Okay, so this is just taking all of these values from here, right the way down, including the 001 there at the end, okay? That's 14 characters in total, so because it's a 16-bit mantissa that we're storing, we need to add on these extra 2 zeros there at the end, okay? So that's my mantissa. Now to work out the exponent, we are going from here. This is your 0 starting point here. So you need to count up how many steps do we have to get to the front of the leading 1. Okay, so this 1 here in 1024 is our most significant bit, it's called. Okay, so the number of jumps that I've got from this point here up to here is 11. Okay, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which means that my exponent then has got to be converted from 11 into binary, okay? Writing that down in binary, we'll find, let me just put this in here, there's my mantissa, so we don't get confused, okay? I'll go along with it. Exponent. Now it's 11, but we want our exponent to be 8-bit exponent notation. So to write that down in 8 bits, it's 8011. Okay, so my mantissa is this value here. So right from all of these values there, plus we had to add on the extra zeros onto there, and then our exponent is 0.00001011. Okay, for question 2, we have got our, again, a large value here, so it's 3165.75. So again, what I'm going to do is convert this into binary as I normally would. So again, I need a 1 in the 2048 column this time. So I'm just going to count these through. I've already done these calculations. I'm not just working this out in my head at the moment. So all of these numbers, if you add up where all the ones are, you will find that they come to 3,165. Okay, let me just check that that's correct. Should be a 1 in there. And then we've got 0.75, which is obviously our 0.5 plus our 0.25 in there. Okay, so writing this down as your mantissa. Again, I'm just going to write in here, text box, mantissa is 1 1 1 2 3 1 0 1 1 0 1 1 1. Okay, now that in total is 1 2 3 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 characters. So I need to add on my other 2 zeros just at the end there, just so that we know that that is my mantissa. Okay, and it's set to your 16 characters. The exponent again this time. We're going from this point here. This time we've got to go to the front of this one here. So the number of steps that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 this time. Okay, so 12 in binary, if I write this down, is just 1, 1, 0, 0. So there is my mantissa, there is my exponent. Okay, last value then is 4,267.875. So you'll notice in my table of values, I've stuck on a 4,096 onto here. I've also got the 3 decimal values there because I'm going to need them. So again, working this out in my head beforehand, I would do the 4,267, put the 1 down for the 4,096 because that fits, subtract that, and you will find that we've got a 0 in there, a 0 in there, a 0 in there, a 0 in there. We need a 1 under the 128, 0 under the 64, 1 under the 32, 0 under the 16, 1 under the 8, 0 under the 4, 1, 1, and then we need 1, 1, and 1 for those values there. So again, writing down my mantissa value here. Leaves me with 1, 1, 2, 3, 4, 1, 0, 1, 0, 1, 0, 1, 1, 1, 2, 3. Okay. Now in total, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 characters. Okay. It's a 16-bit mantissa that we're actually wanting to store. So we don't need to add on any extra zeros this time because we have all our 16 digits that we require. Exponent for this one. This time, obviously, we're coming from here right up to the start of here again. So if I'm correct, that's 12. So let me just count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, 13 this time, okay? So we're going 13. So in binary again, so 0, 0, 0, 0. Remember, it's 8 bits that we're going to put in here. So to get to 13, it's 1, 1, 0, 1. Okay? So that is your mantissa, that is your exponent. Now, if you were to write it out in full, you would just write down your 1, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 1 times 2 to the 0, 0, 0, 0, 1, 1, 0, 1. Okay, but if you were to write that down as your solutions, you would get the correct answers for that one. Okay, the next 3 questions then we're converting smaller numbers this time, okay, but they are already written in binary. So what I'm going to do here is I'm just going to write this out on, just open up a paint value so I can actually draw this for you so you can see what I'm doing. So this first value here then, again, we're writing it out in 16-bit mantissa and 8-bit exponent notation. So we look at the number on there, and we can see then that our values where the ones are, it's just 1, 1, 1. Okay, now what we have to do then is to add on extra zeros to the right-hand side of this for your other values to make it up to your 16 mantissa, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, okay? So that's my mantissa value. Now, the exponent value with this one is slightly different because this time we're actually moving our decimal point to the right-hand side. So we're still moving it from where you can see it in the actual value there. We're still moving it until we get to the left-hand side of the most significant bit. So in this case, we're actually moving it from here, 1, 2 places to there, but it's actually -2, okay? So my exponent is going to be -2. So we need to do a conversion then using 2's complement to get that into a negative number. So the first thing I'm going to do then is I'm going to write down what the positive value for that is, okay? So remember, it's 8 bits that we're using to signify our exponent, okay? So there's my 8 bits for the value of 2. We're going to invert this one. Okay, so remember we invert when we're turning it into a negative. So any zeros that we've got, we turn into ones. Any ones, we turn into zeros. Inverting it, and then we add on 1. Okay, so we need to add 1 onto this side. So 1 plus 1 gives me a 0, carry a 1. 1 plus 0 gives me the 1. And then the rest of these are just all 1s as well. Okay, so our exponent then in this case is 1, 1, 1, 1, 1, 1, 1, 0, and my mantissa is the 1, 1, 1 with all those zeros after it. Okay, so if I was to write down a solution for that one, it would be, put it in here. Okay, for A, it's 1, 1, 1, sorry, 1, 1, 1, 2, 11, 12, 13 zeros, okay, and then it's times 2, and then my exponent then is 1, 2. Okay, so you could write down your solution like that, or you can write it down with the same way that I had it before. Just make it clear which one's the mantissa, which one is the exponent. Okay, you can leave it like that. Okay, so the second one then, I'm going to do it in exactly the same way. Let me just get rid of this. That's going to take too long. Okay, so this one exactly the same as we did before. So if we're getting my mantissa, it's just writing down the actual values that you've got there. So 101, again, it's 16 bits, so I need to add on 13 zeros at the end of here. So we've got our 16 values. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Make sure you leave enough space for that one. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, I didn't need to write them on. Get rid of that. Okay, so that's my mantissa. The exponent this time, again, if you look at the decimal place there, we're going from here back to in front of this one here. So we're going back 1, 2, 3 steps this time. So my exponent then has got to be -3. Okay. Again, it's an 8-bit exponent that we're writing down. So to write down what 8 bits of 3 as 3 is, okay, it is just 8, 1, 1. Okay. Now using 2's complement, I'm going to convert this into a -3. So remember, we invert first, so all of your 1s become zeros and all of your zeros become 1. We then add on our 1, so we add on 1 at the end there. And there is your exponent, okay? So mantissa is 101, 000, 000, 000, and your exponent is 111, 111, 01. Okay, the last value then is, just move this slightly further over so you can actually see it. Slightly different with this one. Again, let me just get a new screen in here. Okay, so we've got our mantissa first of all is 11101, and then we add in our zeros after this as well. Okay, so 5, 2, 4, 6, 8, 9, 10, 11 should work out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 is correct. That's our mantissa. The exponent again for this one, we're going from here to in front of the first one. So that's going 1, 2, 3. So it's also a -3 exponent. So we can just use same version as we did before, but I will write it out for you just so you get a full understanding. So we're writing down the positive value of 3 first of all. We're then converting. So all of your zeros get converted into 1s, all of your 1s get converted into 0, and then we add 1 to the leftmost bit there. So my exponent is 1111, 1101. Okay, so